Hey guys, this is Mrs. Harbin, and we are wrapping up our mini unit on graphing linear inequalities and slope and parallel lines and perpendicular lines. And today we are going to look at graphing linear inequalities. But before we do that, let's just review how to graph on a number line. So let's solve and graph the solution on a number line. This is really just the x-axis here. And when we solve and graph the solution, we're solving for x. So we would divide both sides by 2. And when we do that, we find out that x equals 3. To graph that on a number line, we just put a solid dot right at x equals 3. What about x plus 4 is greater than or equal to 5? Let's solve for x. We need to isolate the variable, so we're going to subtract 4 from both sides. And when we do that, we get x is greater than or equal to, if I can get to the next slide here, 1. We put a solid dot at 1 to show that it's equal to 1, but then we also want to draw an arrow that shows it's greater than. And when we're talking about something being greater than, just remember that greater has that R in it. So greater than means we're going to go to the right. Greater than goes to the right. So solid circle and an arrow going to the right. All right, well, how would we graph this one? Well, first we need to isolate the variables. So it's being multiplied by 3. We need to undo that multiplication with an inverse operation, which is division. And when we divide by -3, what we really want is we're dividing it into opposites here. So everything's going to be opposite. I had a -3x and negative x. Now I'm going to have a positive x. I had a positive 12, and when I divide it by -3, I now have a negative number. So you can see everything is opposite here. We also need to make our sign opposite. So we've got to flip that sign as well when we multiply or divide by a negative. And we get x is greater than -4. Now this is not equal to -4, so we don't want a solid circle. We want an open circle, saying here's where we're starting, but we're not really going to include this -4. And because it is greater than, our arrow does go to the right. Greater than goes to the right. All right, how would we solve and graph this one? Well, just like a regular algebraic equation here, we want to get our x values on one side and isolate them and our non-x values on the other side. And we can do that in a variety of different ways. I could subtract 3x first, and when I do that, I get -x. And then I could add 5 to both sides here, and I get x is greater than -2. But I don't want -x, so I've got to divide by -1. And when I do that, that switches my -x to a positive x. It switches my -2 to a positive 2. And of course, it switches the sign whenever you divide or multiply by a negative. So now I have x is less than 2. Again, it doesn't say equal to 2, so an open circle on the 2. And less than goes to the left. If you're having a hard time, this kind of looks like an L sign, right? An L there, a little sideways L. Less than goes to the left. Our biblical correlation for this unit comes from Job 38:5, where God is saying to Job these words, "Who marked off its dimensions? Surely you know. Who stretched out a measuring line across the sea?" Or measuring line across. And this is God talking to Job saying, who do you think did all of this? Who created this world? Who measured everything? Who set these laws into place and these patterns into place that you have the opportunity to witness and to study? That was me. And we know that if God is a God who measures and creates and does things in an orderly process, we also need to be able to measure and create and do things in an orderly process because we are created in His image. Our lesson objective for today is that you, the student, will graph linear inequalities. A linear inequality is very similar to a linear equation, but linear inequalities contain an inequality sign instead of an equal sign. Our inequality signs that we use are not equal to, less than, greater than, less than or equal to, greater than or equal to. Again, if you're having a hard time, that kind of looks like less. And this sign that looks like an R in greater than. GR as in greater than. Hopefully that will help you remember that. These are the symbols that we use for inequalities, and they have an infinite number of solutions when we represent inequalities. The graph of a linear equation, such as x equals 3 or 2x plus y equals 3, separates our coordinate plane into 3 distinct sets of points. So let's say we were to graph x equals 3. The 3 distinct sets of points that we get are the points that are right on the line, x equals 3, and then we have all the points to the left of the line, or less than 3, and all of the points to the right of the line, or the points that are greater than 3. So you can see we have 3 distinct sets of points. When we are graphing inequalities, we have to consider those 3 points. Where linear equations, we only are concerned about the points on the line. Inequalities, we're concerned about the points to the left or to the right of the line as well. So let's see how we would graph 2x plus y is greater than 3. Just like before, we want to solve for y, and so we're going to do that by subtracting 2x from both sides. Y is greater than negative 2x plus 3. We don't flip the sign unless we're multiplying or dividing. Otherwise, the sign stays the same. Nope, this looks very similar to y equals mx plus b format. The only thing that's different is the sign. Okay? And that truly is the only thing that's different. Our m is still here, the coefficient in front of the x, and our y-intercept is still here. So we can graph this accordingly. Our slope is negative 2, and our y-intercept is 0, 3. Now, this is an inequality, and it says that it's greater than. It doesn't say greater than or equal to, so our solution set does not actually include the points that are on the line. So we can't use a solid line here. We do have to use a dotted line. We also need to determine which way we need to shade. If you remember when we were graphing just inequalities, we had a line going to the left or a line going to the right. Here we're going to shade to the left of the line or to the right of the line. So we also need to determine which way to shade. And there's a couple of different ways that you can do that. Picking a random point and seeing if it works in the solution is one way to go about it, and 0, 0 is an easy choice. If we substitute in 0, 0 into our original inequality, we get that 0 is greater than 3. That's not true, so 0, 0 is not one of our solutions. So we wouldn't want to shade wherever 0, 0 is. The solutions then must be on the other side of the line, not on 0, 0. Now let's take a look at what all this looks like on a graph here. Right, first we want to draw our line. So we have our y-intercept is 3 and our slope is negative 2. So down 2 over 1, down 2 over 1, down 2 over 1. Okay, we would connect our dots with a straight edge, just like we did when graphing lines, but we would make sure that it's a dotted line because it is an inequality, it doesn't actually equal the points that are on the line. Now, we plugged in 0, 0, and we said that that didn't work, so we don't want to shade this side. We want to shade the other side of the line. Another trick that I use to remember this is that this symbol is greater than. Okay, greater than is like above something. If I'm going up in a plane and I want to go to a greater altitude, I'm going to go up, I'm going to go above. So imagine that this is the side of a mountain, and maybe you have a little guy here walking down the side of the mountain, and we want to shade the area that is above him, above his feet, above this mountain, which is this whole area right here. So we're shading up since y is greater than, and it did not include the solution 0, 0. Here are the steps for graphing an inequality, step by step. First, solve for y. Just like we did in y equals mx plus b, solve for y and identify the slope and y-intercept of the corresponding equality. Then, graph the corresponding linear equation. If the inequality is less than or greater than, use a dashed line to indicate that the points on the line are not solutions. If the inequality is less than or equal to or greater than equal to, use a solid line, just like in a linear equation, to indicate that the points are solutions. Then you can choose a test point that is not on the line and substitute it into the inequality to see if it is a solution. If the resulting inequality is true, if it is a solution, you would shade the side that contains your test point. If the inequality is false, then you would shade the other side. Or if you don't want to do a test point, you can just look and see. If it's greater than, so if it's headed this direction, you want to shade above the line. So up here, or if the line's going this way, up here. Okay, if it's less than or equal to, shade below the line. So if the line's going this way, we would shade below. If the line's going this way, this is below the line. So imagine that it's like a mountain here. You're either coloring the sky or the dirt. Let's go ahead and try one together. Let's graph 6x minus 2y is greater than or equal to negative 10. The first thing we want to do is solve for y. So we're going to subtract 6x from both sides and then divide by negative 2. Because we have to divide by a negative, don't forget our sign will change. We get y is less than or equal to 3x plus 5. So our slope is 3 and our y-intercept is 0, 5. Let's go ahead and graph that. Y equals 3x plus 5 with a solid line. It does say it's less than or equal to, so we can keep that line solid. And because it says less than, we want to color under or shade under the line. Right, so here is y equals 3x plus 5. And to make it y is less than 3, we have to shade below the line. Again, imagine that there's somebody climbing a mountain here. We're going to shade the ground under his feet for less than. So all of that blue part there would be shaded. Linear inequalities are often used to model real-life situations in which there are acceptable ranges of values. For example, in grades, you have an acceptable range for an A or an acceptable range for a B and a C, so forth and so on. So linear inequalities can actually be used to model that information because there is a range of acceptable values. The domain, which is all of our x values, and the range, all of our y values, are often limited to non-negative numbers when we're dealing with real-life situations. In this lesson, we graphed linear inequalities, and we learned that if it says greater than, we shade above, less than, we shade below. We also were reminded that when we divide or multiply by a negative number in inequalities, that changes the sign of all the terms, and it also switches or flips our inequality sign as well. Very important. Don't forget to do that. If you have any questions, be sure to write those down and ask me next class.